All right, how are we doing? Foothill biology scholars and anyone else around the world who wants to learn some science. So what I am here to accomplish with you tonight on this wonderful Wednesday evening is this is the quiz that we took in class the other day, and I don't always have time to go over it in this kind of detail. So generally when I give you an assignment, or a quiz, and a lot of times they are difficult. Okay? I don't want to give you easy stuff because that's pointless. I want you to be challenged. I also want to be able to give you the resources to know how to do all this stuff, just in case you're feeling a little overwhelmed. And I don't answer your question in class, so I will do this quite often. If you guys are watching these and they're useful for you, I will keep doing them. So watch them and I'll do them. I have no problem doing these. I enjoy them. I get to write with my cool stylus and make smiley faces all over the place or whatever it is I want to do. So, oh yeah, the handwriting is terrible. I'm bad enough with like a pen, so you give me like a stylus on a screen, and the screen's kind of dirty, but anyway, I don't want to bog it down. Let's cut to the chase. All right, I'm going to give you an insight into my mind when I read these questions, so things that you should consider too when reading. So hopefully this helps you get ready for that retake, which is coming on Monday, I believe. All right, so Balthazar, number one here. Balthazar was experimenting with different factors, okay? So factors are things that can affect something, that affect how well students perform on tests. Which of these is the best question to test for a scientific experiment? All right, so what we want to do is, in a scientific experiment, it has to be testable, okay? Testable. You have to be able to measure it, okay? Things that are easily tested and measured. So let's look at A. Do nice teachers, like me, affect student test scores? Yeah, that would be nice to know. Like, if a teacher is nice, our student's going to do better. That's great. Here's the problem, is this word here, nice. How are you going to find out what's nice and who's not nice? Remember, that's your opinion, all right? Some people might say, hey, Mr. Abling, he's so nice. Some students might say, Mr. Abling, he is not nice. He's a bad guy. I don't like him. So it's opinion. I hope no one says that, but I'm sure there's always one or two. If I had to confiscate your cell phone, you might think that. So we got to get rid of that. No words like that are ever going to make this the right answer. Same thing with letter B. Does eating better food? Okay. How do you measure better? Okay, like when I did my burrito experiment with Faustos and Roberto's. I had to find a way to measure taste, so I did that with noise. Eating better food, that's just not specific enough. Eating higher protein food, that you can measure the protein, but better, it could mean a million things. So always, remember I said the first day, if you see better, okay, it's probably wrong. Why do students do better on tests than others? Okay, that is a good follow-up test, maybe why these students did better, but we need to pick something we're going to be able to test. Okay, so amount of sleep. Does the amount of sleep affect test scores? That's easy to test. Okay, students that got 5 to 8 hours of sleep the night before, how well do they do? Students that got 6 to 10, how well do they do? Okay, that's easy to test. So we're going to go with D on this one after all that. So how I just did that problem is kind of how I want you to do your problems. So in the future, I'm going to give you your own copies of these things so you can cross them out, because I like that. So if you need to cross them out, go ahead. It helps me. All right, we got a little reading to do at number 2. Okay, a student wants to test how red and green mold grows on bread with different moisture. Okay, so there's a lot of words here, and sometimes if you can't figure out really what it's trying to say, ask me and I will help you, because, some of us read like wizards and some of us are like, eh. All right, so what I recommend doing is make drawings. Okay, let's see what we got here. Make some drawings. Okay, we got 5 pieces of wheat bread and 5 pieces of white bread. Put them in a container. So I'm going to just do this. Okay, so we got 2 things. We kind of did this in our bean lab. And 5 pieces of white bread and 5 pieces of wheat bread without water. So it looks like we're testing to see if water results in more mold in a container. So we've got water in this. Well, that's totally mixing up my colors. That's going to just confuse you. We got water, all right, in this group. We got no water. Did it again. No water in this group. All right, so that's what they're testing. Okay, so this one's actually a little tricky because I say there should only be one different thing in each test. Well, you could have two different tests in here. You could have your white bread. Okay, here's your white. Oh, it's red. Mr. Abing, it's red. Okay, and you've got your wheat bread. Okay, and the only thing difference. Oh, hold on. You know what? I'm gonna admit my mistake. No, you'd be messing up, but you just want. Whoa, sometimes it does that. Sorry. You got your white bread. I know WH. White bread. Water here, and then no water here. So you've got your wheat bread with the same thing. So you're going to compare the whites to the whites and the wheats with the wheats. And then we're going to measure for after 7 days to see which one gets the most green and red mold. So just thinking what we can answer here. Okay, we can see if white or wheat bread molds more. Okay, we can see if green and red mold is going to be more. Like which one? Is there more green? Is there more red? That we can answer. We can see, does green mold like white bread more? Does green mold like wheat bread more? Okay, those are things that we can answer from this test. So sorry, my battery here. Let's see what these are. Does water affect the amount of mold that grows on bread? Okay, so this one. That is the purpose of the whole test. That is the fundamental question. So that is definitely one we want to keep. Does white or wheat bread grow more green mold? Well, you just look. Are we measuring white and wheat bread for green mold? Yes, we are. So we can answer that one. Does red or green mold appear first? This one is going to be your wrong answer that actually you need to choose. I'll get back to it in a second. Does wet bread grow more green mold? Okay, then red mold. I do make some goofs sometimes, so thank you for pointing it out, student in my first hour class, whoever you may be. If wet bread has more green mold on it than red mold, you'll be able to tell from this experiment. So it's not C. Why? I made this look very much like your pretest. You're putting them in for 7 days, and then you measure the amount. I'll be honest, not perfectly clear. I could have made this a little more specific. But this is what we're doing in our bean test, okay? We're putting in our two slices, or our two paper towels, and we're putting them away for a few days. And then on Monday, we're going to check. We won't be able to tell when the sprout grows. So we won't be able to answer, does it take 1 day or 2 days to grow the sprout? But we can answer, does 4 days or whatever it is to get to Monday. So here, we can't tell which one, green or red, appears first. Okay, we wouldn't know that from this. So, wow, a lot going on there. That might have been the hardest question, so hopefully it gets easier from there. All right, hopefully I'm not terrifying you like, oh my gosh, how could I think of all these things? Just slow it down. I know sometimes I go fast. Draw, visualize. Sometimes we're good at visualizing. So I'm going to encourage you to draw on your future tests. I've been kind of saving paper. That's my bad. So I apologize for that. I'm not going to buy anything. I don't want to get myself into trouble. All right, here we go. Scotty Joe. Scotty Joe wants to determine if adding salt to water will change how long it takes for the water to boil. So visualize again. Okay, we got a pot with no salt, a pot with, let's say, 5 grams of salt, and a pot with like 10 grams of salt. We're going to boil them all. All right, and we want to see how long it takes for each to boil. So this just comes down to cause and effect. Remember, side effect. Say it again, side effect. That means your cause goes on the bottom. Okay, if you switch them, your graph's going to look really weird. All right, so we got to find our cause. What's going to cause these to be different? Okay, so what is different about all of these? We are making the amount of salt different. So all the ones that don't have amount of salt down here, all right, like this one and this one are going to be wrong. So immediately, sorry guy, all right. And what's the effect? What are we measuring? Okay, now let's look at D. D says the amount of salt will change the number of pots. I don't even know how that's even, I can't even think of any way those two could go together. Let's look at B. Does the amount of salt affect the boiling time? The answer, well, actually, if you're wondering, is yes. So what's going to happen is as you put more salt in, boiling time is going to increase. So this graph really shows that. You could look at this and say, oh yeah, as you get more salt, okay, going this way, your boiling time goes up. So that's why we put the cause here and the effect here. So if you put amount of salt here and boiling time here, it would look strange, all right? So you can do it if you want. So if anyone's reading this or looking at it, listening to it, and they make that graph and put it on a sheet of paper for me, switching these around and then kind of making what it would look like, I'll give you a ticket. All right, anyway. All right, good old Thor. Thor is a great scientist. He notices that algae tends to grow in some of his fish tanks and is curious to see what effect algae has on how long fish live for. All right, so just figure out, what does he want to test? He wants to test algae on the effect on fish. So just, once again, draw. So we got fish tank 1, fish tank 2. We're probably going to put, what, algae in one, and no algae in another one. If you want to see if algae helps fish grow, okay, you would have one with algae, one with no algae. Remember, everything else is the same. So you don't want to put, oh, okay, it's time to draw. You would not, this is not, you would not want to put these kind of fish, that's horrible, that's like a whale actually, over here, and then these kind of fish over here, and then see how they grow, because what are we testing? We just want to test to see if algae affects growth. These fish could grow very differently. What if these fish get huge from algae and these ones don't like algae, or they just don't get big? You won't be able to tell if algae helps these kind of fish. So what we got to do is, I'm going to kill one of these fish. So hopefully I kill the one you don't like as much. Where's my eraser? Eraser, where are you? Oh, I probably got to be on the line. There we go. We're going to get rid of this guy. It's refusing to let me erase it. So, yeah, we're going to get rid of that guy, and we're going to make this long one over here. It's probably going to look nothing like it. Actually, for me, that was pretty good. All right, you got to make the fish the same. So the type of fish, no, that needs to be the same. The size of the tanks. You can't have a tiny little tank here, all right? You can't use like a tiny little thingy tank and a huge tank over here, because of course they're going to grow more in this tank. There's more room. So the tanks should be, you tell me, they should be the same. Oh, my eraser is not working today. That's a problem, because I make a lot of mistakes on these things. The age of the fish. Well, if you put granddaddy fish over here, they're not going to grow very much. And you put little guys, young guys, like, you guys are going to grow a lot, hopefully still, unless you don't want to grow anymore. You don't put young ones over here, so age should be the same. So all these should be like our controls. Like in our bean lab, we had the same type of bag, the same type of towel, the same number of seeds. We tried to use the same amount of water, so we'll see how that went. So your answer is... You're probably like, Mr. Abling, that was really simple. All right, I knew this one right away. Why'd you go through all that? Yeah, I mean, some of you are going to know this, and some of you need a little more explaining. So I'm here to explain. You know what the name of the app is that I'm using, the app? Explain Everything. So I have to explain everything. All right, I'm going to pause. I took a little sip of coffee. And, man, see, I can explain a lot. I know it's 14 minutes for page 1. I'll try to speed it up a little bit here. Okay, a group of researchers, okay, right here, wants to see what driving speed gives the best gas mileage. It's hard to fold, sorry, in 3 different cars. Okay, so what do we know? We got car 1, 2, and 3. We got 3 different cars. They will drive each for 50 miles. So this is going to go 50 miles. This is going to go 50 miles. This is going to go 50 miles. At a set speed of either 30, 40, 50, 60, or 70 miles an hour. Okay, so what do we want to test? We don't know yet. Gas mileage is the amount of miles you can drive on 1 gallon of gas. So if you get a question like this, you're not sure what gas mileage really is, and, okay, I get it, ask me. Because I don't want you to get it wrong because you didn't know that. So they want to see what driving speed. So they're testing for different driving speeds. So that's why those are different. What would be really important to keep the same for cars 1, 2, and 3 that would really make sure it's just the speed that's causing you to get different gas mileage. So let's look at each one. The road being driven on. Okay, if you're driving on a nice flat road, you're going to get even gas mileage. If you're driving on an up and down, hilly, mountainy road like, up around Lake Mead or Red Rocks, you're going to get really bad gas mileage. Trust me on that one. So no, that needs to be the same. The type of gas being used, that's very important. Okay, you're testing to see gas mileage. If you use really high, expensive premium gas, you're probably going to get more. So that should be the same. New tires on each car. I know you guys haven't started driving yet, but if you got really nice tires, and that's supposed to be a nice tire on one, and then really old, raggedy tires, that's going to affect how many miles you get. So maybe I shouldn't have picked gas mileage because a lot of you guys haven't driven yet, but like I said, ask. That'll be important. Now here's one that may not be important, and you might think, well, it should be. The driver of the car. Okay? Why is the driver of the car not important? Well, because they're driving at a set speed on the same road. So really the driver's not doing anything. They're at one speed on the same road for 50 miles. So they're basically holding the steering wheel straight. Plus you would have, you could do it at the same time with 5 different drivers. That would probably be a good idea. Instead of having one guy do it, that would take a long time. This is not important, okay? That's not a big deal. Maybe that's my opinion, but, it wouldn't be. So some things aren't going to be the same as much as you try. All right, here we go. Joffrey, a little shout out for all you Game of Thrones fans. You may be a little young for that. Wants to determine what the better pizza is. Hey Zach, I'm not going crazy. I'm just making a video. Yeah, I'm talking over this thing. So, all right, cool. All right. Joffrey wants to determine what the better pizza is: Sunset Pizza or Napoli. Have you had either of those? Sunset Pizza or Napoli?
I had Sunset. It was nasty.
Okay, so
Right there by Greenway.
I just collected some evidence that said Sunset Pizza's nasty, but like I said, that's an opinion. We haven't had to test it yet. So Joffrey eats 5 slices of cheese at Sunset. 4 hours later, he eats 5 slices of cheese pizza at Napoli and records his level of enjoyment. Okay, so if you haven't picked up on this yet, this is my exact thing I did with the burritos. So if you paid attention, this one should be easy. Which would not be a good change to make for a second test? Okay, so remember all the mistakes I made in my test, and I said this is what I would do to fix it? So what would not be a good idea? What would not be a good fix for Joffrey after he ate these? Okay, so let's look at each one. I like to analyze each answer. Okay, eat both from his kitchen instead of the restaurant. So remember the burrito video? We thought that me eating it in my kitchen would be better because remember, different environments might have impacted my enjoyment. I just want to know about cheese pizza right now. Eat at the same time on different days. So some of you are like, well, Mr. Eibling, you should have had the Faustos and Robertos at the same time on different days. That changes the different times. So maybe I enjoy burritos better for breakfast than I do dinner. Who knows? But that would be. So when you're doing would nots, they're hard. I get it. All right, you got to cross off 3 answers and circle the one that is left over. Okay, so the next day, eat Napoli first and Sunset second. That wouldn't be bad because maybe I could compare those two. So if I eat Napoli first, this time it's kind of fair for both. I'll have Napoli in the morning, I'll have Sunset in the morning, and then I'll also have Sunset at night and Napoli at night. It's going to be this one. Eat cheese pizza at one restaurant and one with toppings at the other. So it might not have anything to do with the Sunset versus Napoli. It just might be the toppings that are going to make them different. So doesn't mean you have to get cheese every time, but you would get sausage at one and then like sausage at the other. Like, Mr. Eibling, pepperoni! Well, that's fine. I'm a sausage guy. I don't know why that's important, but you can learn a lot about me from these videos. Right? I like to add some personality. All right, Lois, how we doing at number 7? She wants to know if a new lotion reduces dryness in her hands for a week. All right, so this is like real life science. What would be the most important to add to her test? Okay, so what should she include in her test? All right, so we've got basically lotion versus no lotion is the test. Drink more water for the days. I don't know why that would really matter. Remember, we're just testing the lotion. We're not testing water, so we don't want to do that. Drink your normal amounts. Use different amounts of lotion for 3 days. No, because remember, we have our difference. Lotion versus no lotion. If we change the amount of the lotion, that could affect our test. Like we use, I don't know how you measure lotion, 10 gobs on day 1, 10 gobs. I don't know why that says TO. That's a 10. 10 gobs on day 1 and 5 gobs on day 2. That could totally change it. Keep your gobs the same. What about wear a glove on the hand without lotion for 3 days? That might seem good, okay? But here's the thing is, you normally don't wear a glove on your hand for 3 days. That's weird. Plus, that would be horrible to go through life for 3 days with a glove on your hand. That's going to change your normal hand. So you want to keep your hand normal. So let's say your left hand has no lotion and your right hand has some lotion. That seems like a pretty good test, right? As long as both hands are kind of equal. Some of you might think, well, there's going to be problems with that. You know, maybe you use your right hand more for things and it gets drier faster. Those are all good things to think about. So I'm glad you're thinking that if you are. That's good science. So your answer for number 7 would be the most, so it would be A. All right? That's your control test. All right, we're getting there. Number 8. Using the above table, which would be the best conclusion about this data and experiment. Consider the purpose of the test. So, the purpose of the test. What is the purpose of the test? Mr. Eibling, it doesn't say. No, but you can look at a data table or a graph and figure out kind of what was going on. So what do we have? We have our cause on the left, okay? Always cause on the left. And our effects are going to be on the right. Okay, so what do we have? Our cause is going to, this one is different. All right, now not all are the same, so I would ignore what I just said. Just think common sense. What's different here? Okay, we have different temperatures, and we have a number of chirps. So as the temperature changes, we're looking at how does that affect the number of chirps? Okay, so I mean basically, do crickets chirp more when it's warm or when it's cold is what it's coming down to. So let's look at the data. So we got 3 different temps. The purpose. Crickets chirping increases the temperature. Okay, now think about it. Is that what they're testing? Are they thinking that this amount of chirps are affecting the temperature? No, because look, the temperature is fixed. They've got 15, 20, and 25. They're fixed temperatures, so those aren't changing. And that would just be a weird test, all right? Crickets chirping, increasing the air temperature. I can tell you it's probably not going to happen. Don't do that test. Please don't do that test. Oh my gosh, don't do that test. B, let's look at B. Increasing the temperature results in more chirps per minute. Well, let's see. I just got an email, sorry. It's on my screen now. I don't know how to get it off. I don't know if you saw that or not. Well, let's see. Increasing the temperature. So we're increasing the temperature going this way. All right, so we want to see, as it gets warmer, do crickets chirp more? Well, we can look at the average. I think that's the easiest way to do. So at 15, it's 83. And then it goes up to 27, and then up to 168. So this looks like a good conclusion. Now, I wanted you to decide between B and C. C is kind of like your best wrong answer. Cricket 5, let's look at it. Cricket 5, okay, chirps the least of all the crickets. And it looks like it probably does. But that doesn't mean that's their conclusion for the experiment. That's why I said consider the purpose. Their purpose is not comparing 5 different crickets. They probably don't care about these 5 different crickets. They're comparing temperature on chirping amount. So I wanted you to use a little reasoning on that one. It's like, man, Mr. Adlin, these questions, I got to think a lot. Yeah, I know. I love me some thinking. Okay, I'm going to go to the next slide. All right, so we are on to page 3 now, and it's not looking as good. We got some blurrage going on here, so I'll try to fill it in for you. Not my best picture. So what question 9 is looking at is just basically which describes what this graph is telling us. So I'm looking at cause and effect. So we see temperature is the cause, and what goes on the side? Effect, side effect. So what that's saying is this is affecting that, or this is changing what's over here. So the temperature is going to affect, what's called vapor. Now, it doesn't matter if you know anything about vapor to get this question right. I'm not testing you that. It's not important to me, but all I need you to know is this is affecting the vapor, the temperature. So it looks like as temperature goes up, vapor pressure goes up. And that's pretty much true. So temperature affects the vapor pressure. So it's B. Okay. Pretty simple there. Number 10. Okay, we got a graph, and it's kind of hard to see, and oh my goodness, we got all these knots. So that means 3 are true. So when you come across one that isn't, that's your correct answer. So let's go through all of them, see what we got. So what are we looking at? Blood sugar after eating a Snickers. So this is what happens to your sugar in your blood after a certain amount of time after eating a Snickers. So basically, you have normal here. It's where you start, 0. And after you eat it, you get a lot of blood sugar, you get a lot of energy. Snickers, hungry, why wait, right? But then the blood sugar drops, and it drops really low, too. And then it levels out back to normal. So let's see. A, does blood sugar, it does not change between 40 and 60 minutes. Well, let's look. 40 and 60 minutes is right here. Does it change? Not really. It's pretty much dead even. Now, I was really hoping no one would look at it really super duper close and see if it went up by like 1 or even just a half or something. I don't think it really did. So that is true. Okay, so that's not our wrong answer. Blood sugar is increasing at 50 minutes. Let's find 50 minutes. Is it increasing right here? No, this is in that chunk of staying the same. So this one is going to be our answer that we circle, because it is not true. That means these are. Blood sugar is the same at 0 as at 40. We have 0 right here, and we have the same blood sugar at 40. Blood sugar is decreasing at 20 minutes. 20 minutes is right here. That is true. Okay, we see it going down like that. So that's when you're starting to get tired. All right, so a lot of times after lunch, 6th hour, you're like, yeah, I'm all ready to rock. And then maybe at about 4 o'clock, you're like, ugh. Okay, that's your blood sugar dropping. See if my eraser works yet. Ooh. Is my eraser working? It is. Okay, it's kind of weird. All right. That's important because I make goofers. Okay, percentages. I'm going to show you a common sense way and a math way. All right, the common sense way, which is what I want. I don't want to turn this into a math class, but let's just look at what we have. We have 150. And when you get these questions, I recommend, doing this. It helps. We start off with 150-gram potato. All right, it's a good-sized potato. And it gained 100% of its weight. What's 100% of anything? It's all of it. So it gained all of it. So it gained 100%. And how much is 100% of 150? It's 150. So you end up with 150 plus 150, and you get 300. So basically, you just double it. You get 100% of something, you double it. All right? If you have $10 and you gain 100% of your money, that's good. You've got $20. Not bad. All right, number 2. Man is measuring the change in owl population in the forest. So that's cool. There are 80 owls. So I'm going to write 80. At the beginning of the year, and the population, it goes up. That means your number is going to be bigger than 80. So let's go ahead and get rid of any answers that are smaller. 55. We know it's not going to be smaller than 80. By 25%. Now remember, do not add 25. So don't do this, okay? Don't add 25 and get 105 and then circle B. No, that's why I put 105 there, because I thought you might do that. That is totally wrong. It's 25%. Okay, so what fraction is 25%? It's 1/4, 1/4. So here's the quick way you can do it in your head if you can do this kind of thing. So I want you to be able to do it this way. 1/4. What's 1/4 of 80? What's basically 80 divided by 4 is 20. So your answer is going to be 80 plus 20 is 100. All right. Now, for all these people that just like to have a mathematical way of doing it, here's how you would do it. Okay, so we take 80. Okay. Multiply it by this. 25% is 0.25. You can put that in your calculator, and you're going to get 20. Okay. And then you add. That's how much it gained. All right. It gained 20. So then you're going to add it to this. And you're going to get 100. All right. We're just going to keep practicing and hammering away at these. But just always think percent, a fraction. I'm going to give you easy numbers until the end of the year. Yay. All right. And the bonus. Now, I'm not going to go into too much detail on this because, oh my gosh, there's a lot of math in here. And it was a bonus. So it was pretty tough. Now, basically, we got starting weights and finishing weights. And we want to see what's going on up here is they want to see if people are gaining weight from this drug. And the questions ask, what conclusion is correct? So if you look at it, let's see, 0 milligrams, they lost a pound. Woohoo! Here we gained 3. All right, so we gained 3 pounds. Here we gained 2.1. And with 300, we gained 2.5. Now, so we got to look at the answer here. Whoa, look at that. 100 milligrams gained the most weight. Okay, it gained the most weight. It gained 3 pounds. That's the most. So you probably thought A was the answer. You probably like, I'm circling A. Look at that. 100 milligrams gave the most, 3 pounds. That's actually wrong. And you're thinking, what? All right, so here's the key. Percent of weight gain. You're thinking, oh my goodness. So he was heavier. He started off at 226 pounds. So he only gained, I don't want to have all the math in front of you, but he only gained, I think, like, let's see, 3 pounds, about 1% of his weight. Okay, that's not a lot. Now 300, let's look at 300. 300 percent of weight. Even though this guy only gained 2.5, he's a little guy. Okay, that's a bigger increase for him. All right, that's a lot. That's like if a rat, all right, let me draw a little rat here, down here at the bottom. Rat. Oh my gosh, that was one of my worst ever. This rat gains a pound. That's huge for the rat. That's a big increase. But if I got an elephant, oh my gosh, this is terrible. I don't even know what I'm doing now. That's actually not elephant. There you go. Arrgh. If I got an elephant who gains a pound, who cares? That's not very much for an elephant. But what if you gain 2 pounds? It's still not much for an elephant. It's still not nearly as close to a bigger increase as that rat. So that's where we're going with that one. So your answer was B. 300 milligrams is the highest percent of weight gain. Really hard. You had to do math. You had to use your calculator for that one. Unless you just kind of guessed, right? All right, number 4, the doctors want to run another study to get more results. Which would not be a change they should make? Okay, so they used 4 men, 4 women. They were all different weighted people, and they took different dosages every day. So let's see. Increase the test to 60 days. That is good. Okay, the longer the test, the more data you get. Increase the amount of people taking each dose. That's always good. More data to collect. Try to use men that have more similar starting weights. That might be a good idea because see what happened here with the different weights. It kind of made it more complicated. Have one of the groups add additional exercise to their daily routine. That violates the key principle of one difference. Okay, the only difference should be the pill dose. So if you are making one guy like run 6 miles a day extra, well, that. They're probably going to gain less weight and lose weight, so it probably has nothing to do with these pills at that point. You're going to get on 100 miles a day on a treadmill. Let's see how these pills affect your weight loss. That's probably going to make an impact. So This one was tricky. So, all right, guys, I'm gonna wrap this puppy up. I'm gonna load this thing on. Well, if you're listening to this, you've already know that I loaded it on something because you've already been there, and I'm just kind of mumbling at this point. So, thanks for watching. If you made it this far, I hope this helped. If you have any questions on this, see me in class, after class, whatever. I think you maybe send me messages on my website. I got to figure out how to do that. But I'm going to be doing a lot of these videos because I like doing them and they help you guys out, hoping. Let me know what you thought of this. Say, Mr. Adling, I watched the video and you know what? I feel better about it. Or, Mr. Adling, I watched your video and it made no sense. None. I wasted 30 minutes of my life. Don't make me feel that bad, though, because I like doing these, and I like to think that they're cool, so. All right, guys. Well, tomorrow's Thursday for me, but you're not going to, yeah, so tomorrow will be Friday, and yeah, go Falcons. Arr.